Hello everyone. Today we are going to determine the natural frequency of a cantilever beam. Here the beam is given of length 320 mm, breadth, depth. The modulus of elasticity of the beam is also given 200 GPa. Here the mass of 225 Newton is attached with a spring of a spring constant of 17,500 Newton per meter. Now we need to determine the natural frequency of this beam. So to determine natural frequency of any system, we have omega equals to root under k by m, where k is the stiffness which is in Newton per meter and m is mass which is kg. So after converting Newton equal to kg times meter per second square, and it will come as 1 by second, which is radian in terms of frequency. So now we need to determine the stiffness of this system. Mass is already given, which is 225 Newton. Now we know that for cantilever beam, deflection equals to PL cube by 3 EI. Here we need to determine the stiffness of this system. So we know that force equal to stiffness times deflection. So therefore stiffness equals to P by delta. Now keeping this in this formula, we get stiffness equals to P by delta equal to 3 EI by L cube. Now I need to determine I. I is the moment of inertia. So I equals to BD cube by 12. So we have B equals 25 mm, D equals 6 mm. So keeping these values, 0.025 into 0.006 PD cube by 12. So after calculating, we get 4.5 into 10 to the power minus 10 meter 4. Now to determine stiffness, K equals 3 into E is already given 200 GPa, so 2 into 10 power 11 into 4.5 into 10 to the power minus 10 by length of the beam is 320 mm. So 0.32 cube. So this will give 8239.74 Newton per meter. Now the stiffness of the beam is calculated. So the beam is displacing. This is going up and this beam is going up and down, and the stiffness K2 is given. K1 is here determined. So we need to calculate equivalent stiffness. Here these both stiffness are also in series, so these are in same direction, so it is in series. So now we will determine 1 by K equivalent equals half K1 plus 1 by K1 plus 1 by K2. So this will give 1 by, we have calculated K1 8239.74 plus the another stiffness of a spring is given 17,500 Newton per meter. 17,500. So this will give 1 by 1.785 into 10 minus 4. So we will get minus 5602 Newton per meter. This is the total stiffness. Now K is calculated we need to determine M. M is already given 225 Newton. So we know that 1 kg equals 9.81 Newton. So therefore this will become 22.93 kg. Now keeping this here, omega equals root under K by M. So this will give K 5602 by M 22.93. So this will give 15.63 radian per second. So we know that omega equals 2 pi f. So f equal to omega by 2 pi. So this will equals to 2.48 hertz. So the natural frequency of this cantilever, this beam, is 2.48 hertz. So in this way the natural frequency is determined. So we can determine the natural frequency of any system by using this way. Thank you so much for watching this video.